So let's see the logical structure of directory. First one will be single level directory. In a single level directory, there is all files stored on a single directory. So if the system may have single user or multiple users, they have one directory to store the information, to store the files. Okay, so what is the problem with this particular single level directory? When you are creating a file, when you create, a user wants to create a file, a user wants to create a file, then he has to check the file name. He has to check the file name that are already exist or not. Okay, if the file name is already exist, you need to add a new file name. You need to add a new file name to that particular file, because once a file name is given, you the file names cannot be given for second time. Okay, so all the file names should have a unique name. Okay, so as the number of files are increased, the system will have, and more than one user will be there, all the files are kept in the same directory, they must have the unique names. Okay, right. So keeping track of all thousands of hundreds of thousands of files within a directory it is a difficult task, because every time you create a file or delete a file, you need to check the file names, and when you create a file, you need to give a different name for the file. You cannot have same file name for uh, two different files that are stored on the same directory. So this will create a lot of name collision problems. Okay? So to solve this particular problem, they introduce one more concept called two level directory. Here we will have two files, first one two directories, first one master file directory and second one user file directory. Okay, so this particular master file directory maintains the information of users, different users, and each user will have a user file directory where this will store one particular user files. Okay, so each user has its own UFD. Each UFD lists only the files of a single user, when a user job starts, the system master file directory is set. Okay, then once the master file directory will be indexed to user file directory. Okay, indexed to user file directory by its username. Each entry points to the UFD of that particular user. Okay, so with the username and login, so that is your login username or login ID, it will point to your user file directory. So master file directory stores the information of users. Okay, where the user file directory stores the information of the corresponding user. So here we have four users, user 1, user 2, user 3, user 4. Each user will have its own user file directories. Okay, so advantage of this one will be name, we can solve the name collision problem. Okay, then this particular we need to specify the path name, because we are using two files, we are using two directories, master file directory and user file directory. So the file name consisting of both master file directories followed by user file directory. That means we need to specify the username and followed by the file name. Okay, so we can treat this particular two level directory as a inverted tree with height equal to 2, where the root node will be your MFD, and then followed by UFD, and then followed by your actual files. Okay, the files will be your leaves, and this one will be your UFD1, and this will be your UFD2, and again there are several files for this particular UFD. So set of all files will be your leaves in a tree. Okay, so we can treat it as inverted tree. The path name will have the both username and file name. And the disadvantage of this particular two level directory, which will isolate the user isolation. Okay, this user isolation, when the user wants to cooperate on the same task or to access the other files, this will lead to some type of synchronization or sharing problems. Okay, so sharing the files of one user to other user will be at some difficult, that will be some difficult. Okay, next see tree structure directory. Okay, so in the tree structure directory, This will allow users to create their own subdirectories. The difference between two-level directory and T-structure directory is two-level directory. Each user has have only one user file directory. Here, even user can create their own directories. Here, they can create their own directories and they can maintain that particular information. They can store files in this particular directory. These directories are special files. Okay, system will treat these directories as special files. The different how to identify how operating system identify differentiate between your directories and files. There is an entry in the directory structure. Okay, one bit entry in the directory structure where the bit is 0, it is a file. Where the bit is 1, it is subdirectory. Okay, so let's see. A tree has a root directory and every file in the system has a unique path name. Okay, so directory and subdirectory contains set of files and subdirectories. A directory or a subdirectory a directory contains set of files and subdirectories. Okay, this directory it is treated as special file. If it is 0, it is a file, and if it is 1, it is a subdirectory. You can see each user has a root directory root where there are directories are there which will points to different directories. So these are actual files. These are actual files and these are your subdirectories where you can find this as subdirectories. Okay, so the path name consists there are two types of path names. First one, absolute path name and relative path name. Relative path name starts from the current file, current directory, where absolute path name starts from the root to the file. Okay, so relative path name means from which directory, current directory to the file, current directory to the file, which will give the path to current directory to the file. So absolute path name begins with the root, follows the path down to the specified file name, giving the directory names on the path. Whereas the relative path name defines a path from the current directory. That means, let's see, this is your, let's see this one. So where this is f1.txt. This f1.txt, what is the path name of f1.txt? Root, programs, p, list, and followed by f1.txt. Okay, so when it comes to this particular file, let's see, this is file.txt. The absolute path name will be root, followed by spell, followed by stat, followed by file.txt. Okay, so this will be the absolute path name. A relative path name will be stat and file.txt. Stat and file.txt. Okay, relative path name includes, and it is a tree. Okay, there will be no cycles inside that particular tree. Okay, so next one is acyclic graph directories. Okay, so acyclic graph directories, we can call it as it is a generalization of tree structure directory. An acyclic graph is a graph with no cycles. Is a graph with no cycles. It allows the directories to share subdirectories and files. That means two users may share the subdirectories and files here. Okay, so here there is a file. I assume that this is f1.txt, and this particular file can be shared by this particular can be shared. So this is a one directory and this is one directory. There will be shared by these two directories. So it will be dictionary count and spell count. So one file may have multiple path names in a cyclic graph directory. Okay, because of this particular sharing. Okay. So with a shared file, only one actual file exists. With any changes made on that particular file or by one particular user are immediately visible to other user. So user one makes some changes, that is change the contents of suppose a equal to 10. They may change a equal to 20. So other user can also see, user 2 can also see. If user 2 made any changes to this particular file a equal to 30, then these particular changes can be seen by user one also. Okay, so sharing is particularly important for subdirectories. When a new file is created by one user, those files will also be seen by user 2. Okay, So Unix implements a shared files and subdirectories by creating a new directory entry called a link. Called a link. A link is effectively an indirect pointer to another file or subdirectory. Okay, and the problem with this particular file that will having multiple file names. So first one, when you search a file, f1.txt. When you search a file f1.txt, we may get multiple path names. We may get multiple path names, even the and different path names, multiple different path names. Even though the path names are different, the file will be same. Path names are different and file will be same. Point number two, when we want to delete this particular file, we have to delete this particular file, and actual, let's see, actual user of this user who has created is user one. Okay, but user 2 also have a pointer to this particular file, also pointer to this particular file. So when we delete this particular thing, this particular file, it may leaves the dangling pointers, but that is the user 2 will have a dangling pointer. That means this particular path name that belongs to user 2, path 2 that belongs to user 2, may they don't find this particular file name. They don't find this particular file name because the file is deleted by the user 1. So user 1 only knows its path name, so the path name will be deleted. User 1 path name will be deleted, but the path 2, okay, absolute path 2 may points to this deleted file that leaves the dangling pointer. That means the file may not, that is pointer that is pointing to the file which already deleted, that is not present in the general graph directory. Okay, so a graph is a acyclic graph with a cycle. The difference between acyclic graphs and graph directory and graph directory is, here we can have the cycles. Here we can have the cycles. The sharing is also possible here. That means this, in this structure also, for a file they may have multiple path names. They may have multiple path names. So we can share files and subdirectories. We can share files and subdirectories. The problem with this particular graph directory is your cycles. Okay, these particular cycles create loops. So if you made a mistake in the writing an algorithm, okay, or if you made any mistakes, the this particular graph directory, that means if you want to search a file, if the file is not present or deleted in between, this will create infinite search. That means the file is not present, the file is deleted at some particular point. This will create an infinite loop. That means the searching, it will a poorly designed algorithm might result in a infinite loop continuously searching through the cycle, and it will be never be terminated. Okay, so there is a solution for this particular problem, that how many loops or cycles will be done. Okay, we can define the number of times the search will be done. That is, we can limit arbitrarily the number of directories that can be accessed during the search. We can find a limitation number, so that the system, once it will reach to that particular number, then the system will automatically stops searching. Okay.